This short presentation is designed to communicate the basic elements of the most common types of positivist research models. The objectives for Part 2 address the topic area of research design in general, with an emphasis on positivist research designs. This information is directly applied within the development of Project Number 2 as well. The presentation is divided into 5 important topics associated with positivist research. First, there's treatment and control groups and your ability to identify which is which. Then there's threats to validity, and there are different types of threats to validity that you'll need to be able to identify. There's pre-experimental research designs, and those will be the most common research designs that are categorized as pre-experimental. There is experimental designs, and again, we'll be presenting the most common types in educational research. And there's quasi-experimental designs, and those will also be the most common types that are found in education research. The first objective addressed in this section focuses on the difference between treatment and control groups within positivist design models. To help you better understand the difference between treatment and control groups, let's consider a study designed to test the effects of banning cell phones in middle school in this case. Suppose a school district is exploring an option to eliminate cell phones in middle school in an effort to improve student achievement. To determine if such a policy change might be effective, the district hires a researcher to investigate. All 12 middle schools in the district are included in the study. Half the schools are randomly assigned to a no cell phone policy, and the other half continue the existing policy of cell phones allowed on campus. Researchers plan to compare standardized test scores from a beginning of the year pretest with scores at the end of the year to measure overall gains in achievement. In experimental research, some subjects are administered an intervention or experimental stimulus called a treatment, and that's assigned to the treatment group, while other subjects are not administered such an intervention. That would be the control group. In this case, the schools assigned to the no cell phone policy is the treatment group because the policy constitutes an intervention that is different from the existing normal condition. Schools adhering to the existing cell phone on campus policy are the control group. Also, on a side note, the variable cell phone use in this design would be considered the independent variable because it's the variable that the researchers are manipulating or changing. And the student achievement would be the dependent variable because any changes to this variable are presumably dependent on the independent variable. That is, if the hypothesis is correct. Another important skill you need to design and interpret research studies is the ability to recognize possible threats to validity. Here's an example of a threat to validity. Suppose the schools in our cell phone study all had roughly the same number of students enrolled, about 300. And suppose at the end of the year, it turned out that the standardized test scores for students in the no cell phone group improved far more dramatically than those in the control group. But something unusual happened in 2 of the schools in the treatment group. 2 schools were located in a part of the community serving many migrant farm workers and their families. Children from these homes typically speak English as a second language, who on average struggle with standardized tests due to language issues. But during the year, many of these families relocated out of the community, so the enrollment in these schools dropped dramatically compared to the other schools. This is an example of a threat to the validity of the results called mortality. Mortality is differential loss of subjects from a comparison group, also known as attrition. Other common threats to validity include maturation. Maturation is where subjects change during the course of the treatment, or even between measurements. Testing is another threat to validity. It's the effect of a pretest or repeated testing on subsequent observations. Instrumentation or instrument decay is a threat to validity where the test itself may have unintended consequences on how the treatment materials are received, or the test may not be implemented in precisely the same way each time. History is an important threat to validity, and that's where a specific event or events that occur during the treatment phase, in addition to the treatment variables, end up affecting the dependent variable. And finally, there is statistical regression, and that's the tendency of groups with extreme scores to test closer to the mean on a second test. So if you scored extremely well the first time you took a test, it is more likely that the next time you took it, you would score closer to the class average. And the same would go for someone who did extremely poorly. And that's just an observable characteristic of groups. There are many different types of positivist research you must be able to identify. Now, the first category of designs is called pre-experimental. To illustrate the types of pre-experimental designs you must be able to identify, let's consider some treatments that might be worth investigating. So one treatment might be the use of mindfulness meditation practices for kids before tests. Another variable that or treatment that might be of interest would be the impact of AI tutors on learning. And another treatment or intervention could be phonics-based reading curriculum versus an existing one that might be not completely phonics-based. So a one-shot case study is a weak pre-experimental design involving just one group that is exposed to a treatment, and then they're post-tested. So for all the examples I'm going to use in these different study types, the child in the meditation sitting position is used to depict the treatment, which could be mindfulness meditation before a test, or it could be the use of AI as a tutor. That could be a treatment. Or it could be, like in our previous example, maybe the use of cell phones or not. It could be the use of a phonics-based curriculum over one that's might include other angles or options or approaches. But so just whenever you see the child in the sitting, that is the treatment. So in a one-shot case study, you introduce the treatment and then you make observations about it. A related weak pre-experimental study is the one-group pre-test post-test. This design involves one group that is pre-tested, they're exposed to that treatment, and then they're post-tested. The static group comparison is another weak experimental design that involves at least two non-equivalent groups. One receives a treatment and both are post-tested. So this is common in education research where two different existing classes are used in a study. So in this case, again, it could be one group, one class gets the mindfulness meditation, the other class, they just run wild. Or it could be one class gets the AI tutoring and the other one doesn't. And then you compare the results based on the same measurement. The static group pre-test post-test design is the same as the static group comparison design, except that both groups are pre-tested. So you must also be able to classify examples of experimental research designs. So here are some of the most common used in educational research. First, there's the randomized control group. It's an experimental design involving at least two randomly formed groups. So you have a group of children and you randomly select from the population. Half will be one group, half will be the other. By the way, it's important to note that experimental designs include random assignments. That's a really important key to it being experimental and not pre-experimental. So you randomly pick groups from a population, and then one group receives a treatment, in this case, the mindfulness meditation, and then both of the groups are post-tested. So the randomized pretest post-test control group design is an experimental design that involves at least two groups randomly selected from a population sample, and then both groups are pre-tested. One group gets the treatment, and then both groups are post-tested. Now, the randomized Solomon 4 group design is an experimental design that involves random assignment of subjects to each of 4 groups. 2 groups are pre-tested, 2 are not. One of the pre-tested groups and one of the unpretested groups receive the experimental treatment, and all 4 groups are post-tested. In this way, you can measure any effects or threats to validity due to the testing threat. Again, this is an excellent design if you suspect that the effects of pretesting would have an influence on the overall results, because you can analyze the data both by treatment as well as by subjects receiving a pretest versus those who do not. This is very powerful in educational research. Now, in education, it is often difficult, impossible, or even unethical to randomly assign subjects to treatment or control groups. The quasi-experimental approach addresses designs that do not include random assignment. Matching is a research design where experimental and control group subjects are matched, but not using random assignment. This design can be useful when, for example, researchers want to ensure that experimental and control groups have the same mix of general ability levels. This graphic here depicts matching subjects by ability and then randomly assigning one member of each pair to the treatment group and the other to a control. This is an important variation in design if ability might be a variable that could impact the dependent variable in a way that you don't want it to. Counterbalanced is a research design where all groups receive all treatments, but each group receives the treatments in a different order, and all groups are post-tested after each treatment. A time series design involves collecting data from subjects in a single group on the same variable at regular intervals over a period of time. This type of design allows researchers to analyze trends, patterns, and the impact of an intervention or event on the observed variable over time. So this presentation provides basic information and examples over elements of basic positivist research design, including being able to identify treatment and control groups, being able to define certain threats to validity, and then being able to identify different pre-experimental research designs, experimental designs, and quasi-experimental designs. So that's it for part 2. Now, for part 3, you will be learning similar concepts, but they will address interpretive research designs.